Hello friends, this is Daniel and today we're going to do something very interesting and entertaining. We are going to create our own fantasy game and we are going to do that by leveraging Moralis and Chainlink. What we are going to do is rather straightforward. We are going to have a dice that in our case is going to have 10 faces, but this is a typical Dungeons and Dragons dice that has much more than that. And depending on the dice roll, we are going to be assigned to either of these mythic races over here. We could be an elf, an orc, a dwarf, a troll, a hobbit, a barbarian, a knight, a centaur, a magician, or a minotaur. These different races can have different powers, but those are expansions that you can add later on. That could be even combined with an NFT kind of contract that provides weapons to each of the characters, and maybe some of the characters cannot use them because they are race specific. So there are a lot of possibilities, but today we're going to do the most basic implementation, which is the roll of a dice and being assigned according to that roll to one of these races. And we are going to make sure that that roll of a dice is actually random by implementing the Chainlink verifiable random function. So I hope that you enjoy. We are going to add a repository with the code of this project in the description of this video so you can play with it. And we are going to implement this one in two phases. First, we're going to connect to the network that we want to implement the contract. In this case, we are going to connect to the Ethereum network and then an smart contract in Solidity. I hope that you enjoy and let's get to it. As a first step, we need to get our endpoint to the Rinkeby network. So we have access to our Rinkeby node and we are able to connect. So to do that, you go to Moralis, you sign up, and you go to Speedy Nodes, Network in Ethereum, and you look for Rinkeby. We have it here, you copy that link, and that's it. That's very easy. Then in our Visual Studio Code, we are going to execute Brownie networks add Ethereum, which is the type of network that we want to add, Rinkeby test, which is the ID or nickname that we're given to this network, and the host, which is the link that we got from Moralis. Remember that I just make these videos and then I reset everything, so you have to go sign up for Moralis and get your own link. You have to add the chain ID that for Rinkeby is 4, and if you want, this is totally optional, you can add an explorer, which is something related to Etherscan to get the APIs in real time. Note that you have that, you will have access when you do Brownie networks list to see your Rinkeby network here. And then when you do Brownie console network Rinkeby test, you will be connected to the Rinkeby network. So that's the way it works to get our network up and running. Now that we have our networks properly configured, we are going to review our very own fantasy game. What we have at the beginning is what we have in any Solidity contract. We have a license identifier and a pragma line to identify the compiler. Then we are importing the BRF consumer base, which is a contract that we can get from the Chainlink smart contract kit, and is the base for any implementation of randomness in Chainlink. For having that one available in your Brown environment, you have to do Brownie pm install and copy this part over here, and that will do the trick. Remember that all of this code is available in the description of this video in the GitHub repository link. So once you have that, if you done it correctly, it's going to appear when you do Brownie pm list, and it's not appearing because I'm not in my virtual environment, so I'm going to do source then being activate. Then we're going to do cd 06 fantasy game. Now we're in, and if you do Brownie pm list, then that part is going to appear here. Now that you have that, then we can proceed to analyze the contract. What we are doing here is that we are inheriting from that BRF consumer base that we're importing here in our fantasy character contract that we are implementing. We are creating several variables here, a key hash, a fee. Those are variables that are important for the random number generator. The key hash is the one that points to the node that will provide the random number, and the fee is whatever fee Chainlink charges for that. That depends on the network, so it really depends. Then we have two maps here. One is for the rollers and the other one for the results. One maps bytes to addresses, the bytes that are the return from a request for randomness, and it maps to an address, and the other one is mapping the addresses to the result of the random number. We also have these events for tracking whether the dice was rolled or the dice landed. Now we have a constructor here, and to this constructor we are sending as parameters the BRF coordinator, which is the Chainlink contract that verifies that the random number is actually random, the address of the link token, and the bytes of the key hash, which is basically what we mentioned before, and the fee. When we trigger this constructor, what it's doing is initializing the constructor of the BRF consumer base, which is our random generator process in Chainlink. And once that is initialized, we can roll the dice. And what we are checking here is that the contract has enough link before rolling the dice, because in each network that causes a fee. And we also verify that whoever rolls the dice have not rolled before, because we allow one specific address or person to be assigned to only one mythic race, which we will see below. We get a request ID as the result, which is this request ID, and that's the chain of bytes that Chainlink will return after we request from randomness. We are going to map that request ID to an address, which is our address. And we are going to have a roller, which is our result of rolling the dice, is going to become roll in progress because we have not received the randomness yet. We have this internal function, fulfill randomness, which is going to be called by Chainlink when they return the value of our random number. Then we are going to make some mod here. We are going to get a residual that is going to be between 0 and 9, right? But since we want to have a random number between 1 and 10, we are adding 1 to that result. So that's what we are mapping to our address here in this part. Then we have this function which takes that result that we have here from the result player and will map it to a mythic race. We have, before executing that function, to confirm that the dice was actually rolled and the roll has finished. That means that Chainlink sent us already the result. We have our mythic races here. We can be an elf, a hobbit, a dwarf, a knight, a magician, an orc, a troll, a barbarian, a centaur, or a minotaur. What we have here is an array of strings with 10 elements. And what we are getting is just mapping whatever was the result from rolling the dice, which we made to be a random number between 1 and 10, to one of these races over here. But since arrays are initialized with 0, the mapping of this array will be from 0 to 9, right? In order to take account for that, we are subtracting 1 from this number that we got, and that's the way that we got our mythic races. Now, let's deploy. Our contract is very generalized. What we have here is all the data that we have from the Chainlink network to deploy our contract. We have our BRF ETH, link ETH, key hash ETH, and we also have that for Binance Smart Chain, and the same for Polygon network. It's not going to be very practical to copy paste while we are deploying. So before we deploy, we need to have some way to manage all of the data that is needed for deployment. So when we want to do a deployment, we very easily just can do import OS from lot.m, import .m, and then we have access in our OS environment of this information that we have inside this .m file. So that's to take advantage of all the generalization that we have in our contract over here, where we are taking all of these things as parameters that are not hard-coded, which actually is a best practice. Now, the other thing that we need before deployment is to set an account. So for setting an account, you have to do brownie accounts, new, set the name of the account, And then Brownie is gonna ask you for your private key, which is something that you have to tell only to your own Brownie and never tell to anyone else. And I already have done that, so I don't have to do it, but I have it here in Brownie, accounts list. And I have here my testing account that it's already set with this private address. So we have everything ready. We can just proceed to deploy. So we're going to do the following. Brownie, console, network, and Rinkeby test. We are in the Rinkeby network. So right now we need to import our environment variables. And for doing that, we do import OS from dapp import load dapp. Then we load our environment variables, and this is done. Now we need to load our account object, and for that we're going to do account is equal to accounts load and testing account. I forgot the equal there. We put the password. We have our account object. So now we can proceed to do our deployment. So we're going to do fantasy character that deploy, and we load our environment variable. So we have OS environment, brf, ETH. We have OS environment, link, ETH. We have OS environment, key hash, ETH, and then we need to submit the fee, which for the Rinkeby network is 1/10 of a link token. So we're going to do 0.01 times 10 to the 18 because of the decimals. Then we load our account, and then we close our parentheses. We are ready for deployment. We are waiting for the confirmation. We got our contract back. Now we need to fund with some link to be able to roll the dice. So for that, we're going to go to Rinkeby testnet, and we're going to send a link to our contract. So we only need 0.1 link. Next, confirm. And let's wait for the transaction to be approved or confirmed. The transaction is apparently confirmed. That's the case. Now we can return to a Visual Studio Code and actually call this contract for rolling the dice. But I already have some deployments of this contract here. So when you have previous deployments, you can do lend fantasy character, and it will tell me two because I have a previous deployment. So when I call the contract, I need to call the index of my latest deployment. The first one is 0, so this one should be 1. And then I can call the roll dice function. I have to send the roll dice function with some seed. So let's put a seed. We got our transaction sent. Let's wait for the confirmation. Now that we have our transaction confirmed, we need to verify what was the race that I was assigned, and let's do that right now. So we do the same fantasy character, the same deployment, but we call the Mythic Race method, and let's check. The roll is still in progress. Let's wait a couple of seconds. and we got a result back. I'm a dwarf in this specific game. So guys, this is the way that you prepare your own Mythic Race assignment smart contract, leveraging the verifiable random function of Chainlink and the speedy node service from Moralis. Remember to smash that like and subscribe to the Moralis channel for more content. This is Daniel. See you in the next video.